Ready, number 36. The table below shows the body temperature in degrees Celsius of a desert spiny lizard at various air temperatures in degrees Celsius. Tell whether the data can be modeled by a linear function, an exponential function, or a quadratic function, and then explain your reasoning. So you'll notice we're looking at the body temperatures. The data is going up, so we know that it's either going to be linear or exponential. And if we just now need to decide, is it going up by a constant amount? So if we look at 33.44 to 33.78, that is going up by 0.34. From 33.78 to 34.12 is also going up by 0.34. The next one is also going up by 0.34, and then the next one is also going up by 0.34. So since this is going up by a constant amount, we know that it is going to be a linear function. So it is linear, and we need to explain our reasoning. That would be because the data is increasing at a constant rate. Okay, problem 37. The pesticide DDT was widely used until it was banned because it is toxic to a wide range of animals and aquatic life and is suspected to cause cancer. DDT takes a long time to disintegrate after it is sprayed. The chart below shows the amount of 100 grams of DDT remaining in the environment after a certain number of years. So if you look at the grams of DDT remaining, we can notice that the numbers in the chart are going down. They're not going back up, so it can't be quadratic, so we know it's either going to be linear or exponential. And if we look at this, we need to see, is it going down by a constant amount? This first one is going down by about 25. The second one is going down by about 12, then by about 6, then by about 3, and then by about 1.5. So notice it's not going down by a constant amount. And actually, if I backwards divided, we would get about 0.5 for all of them. So it actually is not going down by a constant amount, it's actually being cut in half. So this actually is going to be an exponential function. Exponential. And our reasoning would be the data is decreasing, but not by a constant amount. Okay, number 38. During halftime show, a baton twirler releases her baton into the air. The path that follows is shown in the table below. So if you'll notice, we're looking at the height, and again, tell whether the data can be modeled by a linear function, an exponential function, or a quadratic function, and explain your reasoning. I notice that the height in feet is going up, and then right here, it starts going down. So we're going up, and then we are going down. Linear and exponential strictly just go up or down, not both. So it is going to have to be quadratic. And my reasoning is going to be because the baton is going up in the air and then coming back down. So the baton goes up and then back down. All right, problem 39. An art collector purchased a painting worth $1,500. The value of a painting is expected to increase in value 6% each year. A couple things I notice are increase and 6%, and it says to write an exponential function to model the situation. Remember, our exponentials is going to be y equals a times b to the x, and a is our starting amount, so we're going to have 1,500, and then our b is going to be the growth rate. We're going to take our 6% and change it to 0.06 because we're going to move our decimal over 2 places, and then if I increase, we're going to add 1, so 1 plus 0.06 is going to be 1.06, and it will be to the x power. We have to have the x as an exponent because it's an exponential function. Then it says, how much will the painting be worth in 25 years? Now all we need to do is put our 25 in place of the x, and if you do that, we should get $6,437.81. Problem 40. A car is purchased for $16,000. It is expected to decrease in value 20% each year. Once again, we're going to write an exponential function to model the situation. So again, y equals a times b to the x. A is our starting amount, so we're going to have 16,000, and then our growth rate, 20% as a decimal, is going to be 0.20. We're going to move that decimal over 2 places, and decreasing means we're going to do 1 minus that amount. So 1 minus 0.2 is 0.8, and we'll put it to the x because it is an exponential function. And then if I want to know how much the car is worth in 5 years, we'll just take 16,000 times 0.8 to the fifth. And if you do that and type it in, we should get $5,242.81. $0.88, and that will do it.